All right. Good morning, good afternoon, good evening, and welcome to the Architect Podcast brought to you by Unknown Tech. My name is Mike, and I'm looking forward to today's session as we go through and talk about the NVIDIA Certified Enterprise Storage reference architecture with Nutanix. So last week I went through the AI platform, right, design blueprint with Nutanix. Part of that blueprint, of course, had the storage component, and we call our storage NUS, which is Nutanix Unified Storage. And we're going to talk about a little bit about that. We'll get into detail on how that's actually architected, and then we'll get into what it means to enable NUS for AI workloads, specifically in this case, backed by NVIDIA designs and input around their storage requirements. Okay, so before we start, I want to just talk quickly about the quality of the stream. So I'm streaming both to LinkedIn and also YouTube. I do find the YouTube channel has a bit better quality, and you can also chat and interact with chat if there's things going on. Now, I am using a technology called Restream, so there is a delay between what I'm, my live activity, right, as well as when it gets to LinkedIn and YouTube. So I won't be able to answer your chats in real time if you have questions, but I certainly can follow up at the end. We'll go through all the questions that you may have and go through those. The YouTube channel is linked below here, so I'll give you a few seconds if you want to go to that link and not watch the LinkedIn. You can certainly stay on the LinkedIn if you'd like. You'll still see the chats, you just won't be able to interact, and maybe that's okay as long as you can hear me. So, okay, so before we do anything here, again, what we're focusing on is really the Nutanix Unified Storage certification with NVIDIA for AI workloads, right? That's our focus today. If I have time at the end, I may get into topology aware HV, but I may push that to the next session and get more into that. But for now, let's kind of frame the the conversation here like we did last week. So let me just share my screen here. And let me just lower this. Okay, so last week you saw me draw this out, right? Again, everybody talks about the 5-layer cake. Jensen and NVIDIA have their 5-layer cake. I'm not going to get into that, so to speak, but the focus really how we look at things is really, and one of the things that's really missing from here actually goes to the side here. And let me just make this a different color. Okay. And this is really the control plane. Okay. So essentially, ours is also 5 layers, right? It's really around the infrastructure, right? So the infrastructure foundation of what you run your applications on, right? You're going to have some infrastructure, some accelerated compute, networking. In our case, and in some cases, not always, this could be just bare metal, or it could be also running a hypervisor. We have Acropolis hypervisor, which we've just introduced features to make it topology aware. And I'm going to talk about topology awareness maybe later. If not, we'll get to that in the next session because I think it's important to kind of call that out because it is a differentiator between us and everybody else that's doing this out there. And what we're talking about when we talk about multi-tenancy. So, and that's what I'm talking about with the control plane. So it's not just the control plane, but it's also multi-tenant, right? Self, and of course, MSPs would do that, enterprise, right? It's et cetera. The goal here obviously is to leverage the platform, right? And make consumption of the platform pervasive across all of your departments, right? So instead of buying a platform and saying, okay, this platform is only for department X, and now I have this silo, and then I have this other silo for other department X, right? Because I can't segment it out, and because I can't really prioritize. It's not just the segmentation, by the way. It's also the segmentation and function. So, for example, if I need GPU accelerated compute for fine tuning, but my other department is running some inference, right? How do I segment those workloads in my AI platform? Because you're not going to want to have this like multi AI platform within the enterprise for all of your departments, all of your different functions. You're going to want to have a AI platform, right, where your AI platform engineers, and your infrastructure teams run, right, and provide those services back to your end users, right? And those end users could be your customers, right, or the internal customers within your organization. Okay, so that's what I'm talking about when we're talking about infrastructure. The second thing, and what we're really going to focus on today, is really around data services. And I'm going to really get into kind of the storage side of data services, right? Not so much the data services themselves, but the storage side, meaning what is the storage platform that we're going to run these data services on, and how are we going to deliver those for my AI workloads? And in our case, we're talking about model storage. We're talking about RAG, right? RAG capabilities and RAG storage. We're talking about KV cache offload, all of those kind of things combined, right? And then when we move on to AI Data Hub, which is coming towards the end of this year, you'll see a lot more content come out, and we'll talk more about that, right? Because that's going to add on to the data services, okay? Then you have the container orchestration layer, right, which is really around Kubernetes, and we have that component as well. And then the AI platform services, of course, you've seen me, if you watch my previous episodes, really focus in on and really magnify in on the AI consumption layer within our platform. And then, of course, to the right, like I said, the control plane, which kind of controls all of this, right? And I'm going to show you a little bit of that today. But really, I'm going to focus on this area right here, okay? And what I mean by that is I'm going to focus on NUS, which is Nutanix Unified Storage, okay? And Nutanix Unified Storage, like I said, I'm going to talk about what that looks like, okay? I'm going to talk about how that distributed scale out storage platform, right, delivers on massive bandwidth, massive throughput, right, for AI workloads. And of course, it's NVIDIA certified. Okay. So let me just get out of here really quick. And we'll go like this. Bear with me here as I bring some of this information up. So what I'm looking at here is at the portal.nutanix.com. Okay. By the way, you don't need a login to get to the solution documentation. You will get will need a login to get the downloads, of course. And right, typically what happens is if you're a Nutanix customer, you will have a subset of users that manage the Nutanix infrastructure, right, and the solutions that would have access to the portal. Okay. And this portal does a lot of other things. I'm not going to get into it. Of course, support is done through here. Insights, which is our automated machine learning on the back end that looks at errors and gives you recommendations on configurations and all of those things. Okay. But really, where I'm at is under the solutions documentation. So when you log in and you're in home, you can go up to the hamburger menu here, or you can go under documentation. I'm sorry. And you can click it, or you could do the drop down. I clicked it. You can do the drop down, and you can go to solutions documentation. Okay, this is the same document area where it was last week when I was focused on the Nutanix platform design blueprint for AI solutions. Okay, now I want to just make a point here. Part of the design blueprint for AI solutions included unified storage, NVIDIA Certified Enterprise storage, as a matter of fact. Okay. And here's an example of one of the designs we went over yesterday. Okay. Or excuse me, 2 weeks ago. Within this, you can see here you have your GPU, right? Your GPU scalable units. Remember, we talked about scalable units last or 2 weeks ago, and during the session when we reviewed this. And the scalable units really are around the GPU servers, right? The accelerated compute. And what we do with scalable units is we scale by blocks of 4. Okay. Now, within this infrastructure, there are specific network configurations, right? So this design, right, it happens to be the MGX design. And you can see here, it has 8 GPUs. You can have 5 to 9 NICs, right? And some CPUs, right? So again, remember the NVIDIA nomenclature when it comes to the design, right? Okay, I'm not sure if it was in here, I forget, but we'll talk about that in a minute. Essentially, what the nomenclature is, how they define a unit, right, is really around the CPU, right? So how many CPUs are in the server or node, whatever you want to call it? How many GPUs are in that solution? How many NICs, total NICs, right? And what is the bandwidth of those NICs? Okay. So for example, if I have a 2 CPU, 2 socket, right? That's 2. If I have 8 GPUs in that node, it's 8. If I have 5 NICs or 9 NICs, let's just say it's 9, and say those NICs are 400 gig, it would be a 2, 8, 9, 400 gig unit of scale when it comes to definitions around NVIDIA. All right, so we're going to talk more about that in a little while. But what I want to focus on is, of course, you have your east-west traffic for the GPU to GPU connectivity, right? And I'm not talking about GPU within a node, because remember, if a GPU, if and especially in the MGX, right, you have GPUs in there, and they will communicate with each other, but you also will have other nodes outside of that server, right, that have GPUs. How do they communicate? Right? Well, they communicate over high speed networking, whether that's ConnectX 7, 8, or it's Bluefield DPUs, right? Or a combination of those. I've seen a combination of Bluefield and ConnectX in the platform. I've seen complete ConnectX and I've seen complete Bluefield. Okay. It's a combination of those things. Now, of course, Bluefield adds additional features for offload, right? That's why I call it the data processing unit, not a network not a network device, right? It's a data processing unit because it has on the Bluefield NIC, it has, or DPU, I should be very careful how I say that. It has its own compute and memory on it, right? And you can offload specific features, like you can offload network security features, okay? You can offload storage features, right? So that's what the DPU is for, is to provide that offload. Now, I'm not saying ConnectX 7 or 8 can't do offload. It can, but it's more on the networking side, okay? More focused on the networking side. Now, within this design, you also have dedicated north-south. So remember, your east-west is your communication within the cluster. So internode and intranode. Intranode is more around NVLink, right? Or PCIe bus, right? NVLink, connecting GPU to GPU within a node, right? And then you have NV switch, and then you have your ConnectX 878s or your Bluefields connecting node to node, so GPU to GPU that way. All right, giving you massive throughput. Remember, the GPUs have massive throughput capability by themselves. And when you leave the boundary of the server, right, generally speaking, you start running into network limitations. And so the idea is to remove those network limitations with high speed 800 gigabit, 400, 200 gigabit east-west connectivity. The north-south connectivity is really around your workload, your application access, right? So your AI application, your agents, all of those things, that access, as well as your storage solution, right? So you can see here, we have, let me just get rid of this. You have the Nutanix Unified Storage Cluster sitting here. Okay. And by the way, don't count the number of nodes here. We're going to talk about how this scales here in a little bit. But this is the servers, the dedicated, all right, can be dedicated, can be shared. We'll talk a little bit about that. I would say for the most part, you'd want dedicated storage clusters for this. That way it only focuses on the serving the storage component for your AI workloads. And this is where the models will be stored. Right. So here you're going to have models, right? You're going to have KV cache offload, right? As a tier, you're going to have AI apps agentic memory offload. We'll just say agentic memory. Could have your vector database storage. Could have your ingest pipeline storage. So the ingest pipeline, meaning bringing your data in to go through a pipeline process, right, to make it AI ready, right, to go through that that pipeline, those phases, right, where you're taking that data and you're making that data AI ready, okay, and so this is what I'm talking about when it comes to storage capability, and some of these things, right, will require to have like direct access to GPUs, right, using GPU direct capabilities. Okay. And so that's very, very important. If I can bypass the CPU, right, if I can bypass the memory and CPU bottleneck within the platform and feed it directly into the GPUs, right, I'm getting massive benefits from that. And that's what NVIDIA GPU direct storage capability provides. And that's part of what we're going to talk about today. So, what does, and let me just get rid of this. What does this kind of look like, right? What does NUS look like within a single NUS node, and how is it configured? So remember, I talked about Nutanix, and let me just go back here really quick. And let me just, what I'm going to do is I'm going to draw with this. So with Nutanix, right, you have nodes. Within those nodes, you have compute, storage, memory, networking. Okay. Now, every node has a CVM. That's what this little box is up. This is the controller. Okay. And the CVM is what has direct access to the disks. Let's just say that's the disk, right? Through the HBAs, right? Right. And now I can now present back or build my block storage right underneath, right? So here's my block storage underneath. I'm not going to talk about what we do as far as what it's called. I mean, we can say they're VDIS, but I'm not going to really focus on that right now. I'm going to just say that this is block storage. Now, obviously, that's not file storage. That's not NFS, right? That's block storage capability. So how do we provide file services on that platform, right? So how we do that is we basically take and this is a single node, right? So now we're going to drill down into a single server. You have, again, NICs, you have storage, you have compute, etc., and you have these services running on. At the very core, you're going to have Nutanix AOS, which is our scale-out storage, right? Our distributed storage, which is running, right? And that runs in this CVM here. See this CVM? That runs in that controller virtual machine. That's where AOS runs. And that's where all the magic happens when it comes to storage services. Now, in order for us to basically provide you the unstructured data services, we built what's called a file services VM, an FSVM. Okay. And that FSVM sits on the same node, right, as the CVM. All right. And how this gets divvied up, and this is more around the networking because I think this is extremely important. Okay. You have the file services VM and you have the CVM. What happens is on this side of the equation, okay, you essentially have storage access, right? This storage network, okay? This AOS storage network is an RDMA storage network, and this network is basically on its own separate VLAN, right, and own separate NIC, okay? You can see it here. And that will be on every node in the cluster. So basically what I'm doing is I'm segmenting the storage traffic, right, for my file service VMs. Okay, and that's and I'm clustering that traffic over an RDMA network. Okay. And you can see here how it's clustered. This is showing that it's clustered to CVM1 running on node 1, CVM2 running on node 2, CVM3 running on node 3, et cetera, depending on the scale that you need for the clustered storage. It's a distributed solution. So you at least need to start with 3 file service VMs. Now you can do one in edge location, but for all intents and purposes, for this discussion around AI, you have to at least start with 3. I think it may start with more. We'll talk about that scalable unit in a minute. Okay. Now the block storage is connected, right, presented to the file service VM over iSCSI. Then what we found is that there is some offload that we can do with iSCSI, right? So that's why we have iSCSI over RDMA. And you can see that this NIC right here, this P4, this interface on this NIC2 is not connected to anything. There's no uplink. Because all that's doing is it's doing offload functions, right, for iSCSI, right, over RDMA. And so essentially what we have here is we have the iSCSI connectivity, which is basically providing the block storage to the file service VM, and it's it's accelerated, hardware accelerated from this NIC interface with no uplinks using iSCSI over RDMA. We're offloading that to the NIC. Okay. And now that's presented as block storage to the file service VM. All right. And we call them volume groups. Okay. Now that we had the volume groups on the file service VM, right? So you have all these volumes groups attached, right, to the file service VM. We have to now, provide a files, right, a filer component to provide SMB, NFS, right, and front end that back out to this network interface here using SRIOV, right, and providing access for the client network here. Okay, so this right here is where your GPU nodes will communicate on. Not just GPU nodes, but other things too. But for this conversation, we're really going to focus on GPU nodes. It's going to be right here. Okay. And then here is your management component, right? So I'm not really going to focus on the management so much, but this NIC will handle your management, right? It basically handles like all of the management side of it, right? The CVM to CVM management, right? Remember, it's a cluster. It's a distributed fabric, and so there is quorum. There's those things that have to happen. There is health, right? There is alerting. And within our distributed storage fabric, the CVM handles all of that. There are many different services running on the CVM. One of them is including Stargate, right? Which, basically is the storage interface, right, for the cluster. And essentially what we're doing here is we're basically segmenting up the network connectivity to do different functions, right? So again, the management network, right? The RDMA backend storage network, right? So this is your private segmented VLAN, right? Physically segmented and logically segmented RDMA storage network. And then your ISER network, which has no uplinks, where this NIC is just offloading iSCSI, right, to present the block storage back to the file service VM. Then the file service VM basically has the software to present these protocols, right, back to the client network, right? And that's basically how it operates on a per node level. Okay, so again, this is our storage, and again, we give a lot of detail on this. To be honest with you, there's not a lot of other solutions out there that give this much detail on how we do things in our storage fabric. Okay, and you're going to see the benefits of using all of these technologies here in a minute when I talk about what we're really delivering here. So if we go back to the documentation and you do your descending order of last updated, you're going to scroll down to NVIDIA Certified Enterprise Storage. That's what we're going to focus on today. So when we click this, right, we're going to give you an overview, right? We're going to talk about what we're basically designing around. What's the NVIDIA Certified Nutanix Unified Storage Architecture, our decisions, right? Our integration points, and our scaling guidance to enable enterprise AI factories. So going back to this document, this Nutanix platform design blueprint, the idea is to really focus on the areas around storage, right? So while the design blueprint talks about the scalable units, the storage, right? We're now drilling into this area, right? And getting deeper on what this looks like. So you can plug this in to the Nutanix platform design AI solutions or not. And what I mean by that is you could just buy this from a storage perspective. So, for example, and this is the beauty about it, Nutanix NUS, right? You can buy as a separate storage solution just for your AI workloads. It doesn't even have to be running all Nutanix, even though you definitely get a much better benefit by going a full stack route, right? Because you get that full integration, the simplification, right? The time to value, you get that ROI when it comes to operations, right? All of those things you gain. But I will tell you that you can still do this and connect out to a platform that has nothing to do with Nutanix, right? As long as it's built for the environment we're talking about, right? These designs that NVIDIA puts forward, these scalable units. Okay. All right. So let's get back to the document here. So this solution really certifies the NUS, right? And when you see NUS, I'm talking about Nutanix Unified Storage. It's been built on the NVIDIA Enterprise Reference Architecture and can satisfy scale deployment requirements up to 1,024 NVIDIA GPUs. Right? RTX Pro servers are supported, up to 16 racks of NVL72 platforms. We require NVIDIA Spectrum Ethernet networking, and we're using the Nutanix Unified Storage Elite reference design. Okay. There's definitely a difference between Nutanix Unified Storage when it comes to, I'm servicing home directories, right? Or I'm doing some application storage versus running this for AI. It's a little bit different, and there's some requirements around that when it comes to delivering the throughput. So basically, the solution combines in Nutanix and NVIDIA products to enable AI factories and support workloads such as model training, inference, fine-tuning, and RAG. Okay. So because we're using, because it is NVIDIA certified and it's using NVIDIA GPUs and Spectrum-X Ethernet networking with Nutanix distributed storage, it's scalable, resilient, and provides this high throughput that's required for AI demands. So we're going to really focus on the NUS overview and benefits, Nutanix NVIDIA partnership, and the certified architecture from NVIDIA. So basically what we're delivering here in this use case, and by the way, I just want to focus, I'll talk about this here in a minute, but we're really focused on, in this design, we're really focused on this right here. So NUS can deliver a combination of technology. We can deliver block storage, we can deliver object services, S3 compatible, as well as file services. And we're really going to be focused on the file services component. But you can certainly leverage for things like RAG as an example. If you want to run Milvus like on S3, you certainly can run that on NUS as an example, right? And of course, you may have other needs around object storage, right? When it comes to your AI applications, right? It may not just be files. You may want to look at objects. So now there is no objects design for AI yet, but you can look at the objects design that we have in the NVD, which is our Nutanix validated design for NUS. Okay. You can deploy it within the hyperconverged solution, or you can deploy it as a dedicated storage solution. And you're more along the lines, you're going to be focused here. Okay. I did talk last week about in the blueprint, right, design that we talked about for the Nutanix solution blueprint for AI solutions. There are solutions in there where you had the Nutanix unified storage, right, NUS running on the management cluster. Okay. That's doable in specific entry-level AI use cases. Okay. But when you start looking at inference at scale, agentic inference at scale, all of those things, right? You're going to want to deploy a dedicated storage, right? Cluster. So it's just solely delivering storage capability back to the GPU workloads, right? Your AI workloads. And, we provide this global namespace. We give you global visibility with Nutanix Central and global data management with Data Lens. And so that's another thing that we don't really focus so much. We talk about it a little bit, but Data Lens really is that governance layer around all the data running on NUS, right? So it looks at anomalies, does ransomware protection, all of those things, and recovery, all of those things, right? And so that's an important aspect as you look into your solutions, especially for AI, that it's still, governance is still a requirement, right? All those things are still required, whether it's a home directory or a model storage or, RAG, right? You want it to be governed. You want to have ransomware protection and recovery. You want all of those things. And so we provide that with Data Lens, right? For both objects and files. Okay. All right. So let's move on here. So basically, we're building this, right, certification with parallel NFS, which provides high concurrent reads and writes for AI training, fine tuning, and checkpointing. Metadata is often a bottleneck for large scale AI factories, but Nutanix Unified Storage enables clients to bypass metadata and connect directly to the storage node. So what we're talking about here is NVIDIA GPU direct storage, right? And we couple that with RDMA over Converged Ethernet, right? And it's basically NFS, parallel NFS over RDMA. Okay. And I showed you that in this diagram here on the segmentation. Okay. So you have your files, client access, you have RDMA enabled here, right? You have iSCSI over RDMA. That's more internal. That's more of an internal offload, right? But this external offload is really down here at the RDMA storage network and the client network here. Okay. So you get rich enterprise AI stack, right? Of course, we always talk about our high net promoter score. We have an industry leading net promoter score of 90 plus, right? You can ingest unified block file object over multiple protocols on the same Nutanix unified storage clusters. AI operations near the data. So one of the benefits of having this, right, you basically can, you run this, right, deploying AI close to the data can minimize latency, reduce network bottlenecks, eliminate vendor sprawl. The idea really is providing a compute adjacent architecture, right? What I mean by that is you have your GPU compute, your accelerated compute, and right next to that, adjacent to that, is your storage network, right? Your storage environment. And you can run GPU accelerated compute nodes alongside high density storage nodes, right, on the same unified cluster to give you data pipelines, embedding models, vector processing directly where your enterprise data resides. Okay. And of course, we offer Nutanix as an AI platform as well. Remember, I talked about this, right? We look at this as an entire AI platform, the agentic AI platform. And, really, it's around these components here. All right. That is the Nutanix AI platform. And we can play in all of these areas. Okay. We can provide you a full stack solution that's all integrated, or you can say, okay, I only want Nutanix at the foundation, or I want just the data services, which we're talking about today, or I only want to do Kubernetes with Nutanix, or I only want to do the platform services, or I want to do a combination of two, right? Or three, or four, or maybe I have my storage and I'm using something else outside of that, right? Maybe I'm using Everpure or whatever. So you have this flexibility, all right, as far as how you can consume Nutanix when it comes to the AI platform or your AI platform or any workload for that matter, not just AI, right? So if you took AI platform services out of this, right, we still have Kubernetes, we still have data services, right? We still have virtualization, we still have all of those things, right? That you can still leverage even if it's not AI, right? That's what I'm talking about. So you have that full flexibility that people are looking for today. So again, this is what this AI platform talks about. And of course, it could be federated, right? So you can enable this unified storage, right, to be federated across on-premises and cloud environments. And this is extremely, or the edge. So this is extremely important because generally speaking, you're not doing your AI services in one location, right? You may have edge AI, you may have data center, right, enterprise AI, and you may have AI services you're using in the cloud. And this federation supports model training, right, and globally distributed data centers, right? Whether it's in the cloud, whether you're using a hyperscaler or you're using a colo, or you're at the edge, or you're in your data centers, right? All of those can be mixed and matched. Of course, as long as you have connectivity, right? That's the important thing. We do offer cloud native file storage, right? So we're extending, the file services into the cloud, and you can do this in a couple ways. You can run Nutanix Unified Storage on Nutanix in the cloud, or you can run it on native cloud backend. So, for example, if you want to run native Unified Storage and leverage EC2 as the compute and EBS as the block storage for files, you can do that as well. So you have the flexibility here. And a lot of customers, again, like I said, are looking for that. We talked about data governance with Data Lens. I'm not going to get into that. It is consumer grade simplicity, right? So there's one-click upgrades, non-disruptive, automated load balancing, right? All of these things are extremely important, right? To operate your in this highly robust, highly leveraged, right, infrastructure. Zero impact to resilience, right? Can handle component, drive, node failures, non-disruptive support, online expansion, right? If you need to scale down or scale up or scale out with Filer, you could do that. So, for example, if you need to add more file service VMs, or you need to add more compute and memory to those file service VMs, you can do that, right? And those are all non-disruptive operations. We're reducing risk because we're following the blueprint from NVIDIA and Nutanix. So it's a combined solution, right? And there's guaranteed interoperability because of that, because it's NVIDIA certified. And we're providing maximum GPU efficiency. You're going to see this in a minute. Nutanix storage performance isn't the bottleneck, right? So when you look at solutions, right, your storage solutions for your AI platform, you're thinking, oh, I can't use a name brand solution. I can't go out and use my standard, Dell solution or whatever. And in those cases, maybe you're right. But in our case with Nutanix, we have designed this solution to be scalable, to provide maximum throughput, and you're going to see that throughput here in a little bit. So this design, right, includes accelerated computing, right, Spectrum X Ethernet platforms, as well as switches and Bluefield DPUs, right, SuperNICs, right, or ConnectX-7 or ConnectX-7, right, or 8 NICs, okay? We're supporting NVIDIA Spectrum Ethernet, RDMA over Converged Ethernet, East-West, right, for East-West between GPU compute servers. NVIDIA recommends a Bluefield 3 SuperNIC for each GPU server. This configure provides high latency, whatever, okay? We know that. For North-South, right, so that's compute to storage networking. That's included in the North-South connectivity. NVIDIA recommends the Bluefield 3, right, which offload networking tasks for CPU and reduce bottlenecks. So we saw this in the design 2 weeks ago. We do have a couple options, right, when it comes to what we can deliver. We have 1U solutions that are optimized for performance, right, and in a compact rack footprint. So ideal for environments prioritizing performance per rack unit, right? And then we have 2U RU configurations, which are still high performant, but also optimized for capacity, provides required performance profile and higher storage capacity per rack unit, making it suitable for deployments where storage density plus the performance is a key consideration. So the point I'm trying to make is, even though the 2RU, right, gives you more density, we're not sacrificing performance. And I think that should have been called out in this, right? That's probably some feedback I'll give the team. When people look at storage density, right, sometimes they don't align performance to that, right? They focus on storage density. Oh, I need a whole bunch of bulk storage. That's not what we're talking about here. We're just basically saying that you have an option to have higher storage density with the same performance profile. Okay. So you have the NVIDIA Certified Hardware Configuration Overview, right? It's based on cluster sizing. We'll talk about that a little bit later. Node form factor, 1 or 2 RU. We talked about that. Storage media all has to be triple level cell TLC NVMe drives. Okay. So this is low latency, high throughput, and can tolerate, right, many terabytes of writes, right, without failure. So it's not just, they're low latency and high throughput, but also they are very high reliability, right? So mean time to failure or failure based on how many terabytes written to it, right, is extremely important as well. And then networking per node, right? You could do 3 ConnectX-7 minimum 200 gig high bandwidth. So this can change, right, based on what we're trying to deliver as far as performance. But high bandwidth RDMA capable fabric integration is a requirement. We talked about this last week. This is basically how each storage node will be connected up to the physical network, right? You have your NICs, right, within the node itself doing specific things, right? So again, this is your client network here, active backup here in red. Your blue is your backplane, your storage backplane. Remember, I talked about your RDMA storage backplane, right? That's your private network for storage. That will have its own VLAN, its own physical NIC. Same thing for your client access, own VLAN, own physical NIC. And then you'll have the management ports, right? And block storage backplane backup, right? So that's green and blue. So you can see here that we're doing this here. Now, one thing it doesn't call out because there's no uplink is this NIC port right here, right? This is iSer. So that's delivering the iSCSI over RDMA, right, for the offload. There is no physical uplink. That's why it's not on this diagram. But this NIC is used, right? This NIC port's being used for the iSCSI over RDMA configuration, okay? So that's what we're talking about here when it comes to the network topology, right? The physical connectivity and what each of those physical connectivity pieces do. Nope. The certified Nutanix storage reference configuration uses a 10-node cluster, which exceeds the enterprise baseline performance requirements of 512 GPUs. Physical connection count, 6 by 200 gig connections per storage, okay? So, again, this is the 512 GPU configuration. We'll talk more about the configuration here in a minute. But I want to talk about some of the build outs here. So you're going to have a few of these. Remember, we talked about these NVIDIA CPU GPU NIC bandwidth notations that NVIDIA uses, right? 285, 200, which means 2 ZPUs, 8 GPUs, 5 NICs, 200 gig networking, okay? These server configurations create the building blocks of AI compute and storage with unified storage. Each building block, known as a scalable unit, consists of 4 compute nodes. So you'll see 4 of these, right, is a scalable unit. I want to make that very clear. A scalable unit isn't a single server. In our design, or the NVIDIA design, a scalable unit is quantity 4. So this is a server, right? Times 4. All right. And as you scale, you will scale by 4. So 4 more, 4 more. That's the scalable unit. That's how you will scale this out. Okay. In the 285, right, configuration, right, you see here, remember, it says Bluefield or ConnectX-7, right? Again, like I said, I've seen this with a ConnectX-7 or 8 or just Bluefield. And I've also seen a mix of Bluefield and ConnectX-7. We don't really talk about that, but I've seen that mix as well. Current GPU models include NVIDIA RTX 6000 Pro Blackwell servers and H200 NVL, right? So this is your PCI-based solutions. What I mean by that is It's not a baseboard solution. It's PCIe based on the motherboard itself. Okay, so you have your RTX Pro 6000s, Blackwells, right? Which are, I believe, yeah, those are two. They take two slots, right? They cover a slot. They take one PCIe slot, but they cover a slot, depending on how your slots are kind of spread out, right? And then you have your H200 NVL. So the NVIDIA RTX 6000 Pro Blackwell is 96 gigabytes of RAM, and the H200 NVL, I believe, is 141. I have to double check. H200 NVL, I believe it's 140 something gigabytes of HBM3. So this is GDDR7 and this is HBM3. And so you're going to have to figure out, and we can help you, right? Figure out exactly what you need for your AI use cases, what would make more sense, right? So obviously the H200 NVLs, much more, much higher memory, much higher memory bandwidth than the RTX 6000 Pros. So, you may be doing some really deep, agentic inference or something with these. And with these, maybe you're doing some low end agentic inference or inference, right? Chatbots, things like that. I'm not saying that the RTX 6000 Pro isn't capable, but remember that these are PCIe based. And so now you're relying on the motherboard, the main board, PCI switch, and the PCI bandwidth, which isn't great, by the way. It's nothing like the MGX, right? Or or the, not the MGX. I take that back. Not the single baseboard solutions that have NVLink configured, right? Because NVLink is really, really fast. Now you can do NVLink with this. I'm not saying you can't, but on the baseboards, right? The NVLinks on like the GB300s, the throughput is unbelievable, right? It's just crazy. And we'll talk about that here in a few minutes. But essentially, this is your 285-200 configuration. You'll have your north-south NIC here. I'm not sure. Here it is right here, your B3220. This will be the connection for your north-south traffic and the NUS storage. Everything else will be GPU node to GPU or interconnected through NVLink, right? So you have NVLink, which is intra-node, and you have your blue fields or your ConnectX-7, right, which are internode, so between nodes, okay? And this is really for medium-sized LLM, can run superior performance for RAG, classification, virtual assistant use cases. Medium-sized for AI training, fine-tuning. Enterprises can take models and customize them with internal secure data to enhance productivity. Next is your 289-400. So that's 2 CPUs, 8 GPUs, 9 NICs, but they're at 400 gig network speed, right? So this is your HGX. The HGX has a baseboard, okay? So this baseboard down here, right, has NVLink built into it. So the GPU to GPU is extremely fast. But then when you want to go to another one of these, right, over here, right, how do I connect to that? Well, you're going to use this 400 gig link, these links, right, for east-west traffic between the two, okay? All right, so this would have GPUs. This would be basically a mirror. This is one solution. This is one system, by the way. All right, this is what I'm talking about. This right here is one server, okay? And so you're going to have multiples of these, right, as you scale out. And if you're going to do it in 4 scalable units, you're going to start with 4. And so you have to have that connectivity, that east-west connectivity, right, to support that. And in this case, this has a booth B3220, same thing for your storage connectivity down here, okay? This is basically hosting large per node, medium per GPU models. This design can benefit, workloads, marketing and ads, video, library creation, engineering and modeling. Small to large model training, you can fine tune larger models for automotive, pharmaceutical, and video use cases, okay? When you move from PCIe-based NVL, H200 NVL, or RTX Pro 6000 to B200, et cetera, right, HGX systems, it's a completely different animal when it comes to performance and capability. Now, here's the Grace platform. This is a ARM So this is Grace Blackwell. Okay. So this basically has the NVL2 GH200 super chip. All right. So 2 CPUs ARM, 2 GPUs, 3 NICs, 400 gig east-west networking. So this is the platform here. And this will also contain a B3 3220 for your storage connectivity. Okay. This is memory intensive, single node, large language models, retrieval augmented generation, pipeline, speed and precision. Now we're talking about classification, graph neural networks, is extensively in pharmaceutical drug discovery, recommender systems, traffic forecasts, and social analysts. Memory bandwidth, you see here, NVLink, 900 gig. This is what we're talking about. Memory bandwidth is extremely important to address those types of use cases. And so therefore, that's why you would look at a platform like this. So what does this look like from an NVIDIA enterprise storage use case? Well, this is how you would align what we're talking about here. So remember, one scalable unit equals 4. Okay. And you don't scale, you don't go to like 3 scalable units. You go 1, 2, 4, 8, 12, right? You go, right? Not quite like double, but this is kind of the scalable units, how you would architect this. So you start at 4, which really could give you 32 GPUs, 8 CPUs, it would require 4 Nutanix unified storage nodes and would give you roughly 10 gigabytes per second of read, 5 gigabytes per second of write throughput over 800 gig networking, right? So in this case, right, you would basically have, it would be a 2, 8, I believe 5, 800 gig networking. That's what would be that each node, each NVIDIA node would look like. But you can see here, as you scale up, we can provide additional throughput even within the same Nutanix unified storage. 20, count, right, 4 nodes, 20 gigabytes, 10 gigabytes, 5 nodes, 40 gigabytes, 20 gigabytes, all the way up to supporting 1,024 GPUs, 64 CPUs, okay, 128 nodes, 32 scalable units, and 160 gigabytes of read and 80 gigabytes of write throughput. Okay. So the bottleneck, it will not be storage. Okay. We're giving you massive, and we're doing this, by the way, in 13 nodes. So 13 Nutanix unified storage nodes are delivering this optimized platform supporting up to 1,024 GPUs. All right. So that's basically the overview of the NVIDIA enterprise storage with Nutanix architecture, reference architecture, right, and guidance. And this is easily plugged into the design that we talked about for the actual. If we go back here, hang on one second. Solution documentation. You could easily plug that into the platform design blueprint for AI solutions. Okay. So when we go down to the cluster architecture, and we start looking at compute, we start looking at, hang on, let me just look at this here. When you start looking at designing this out, right, you can now plug that into, and understand what is required from a throughput perspective, right? So if you know that you need like massive throughput, you need to support this many GPUs. So for example, say you need to support based on this. Oh, what did I do? Oh, hang on. Sorry. I closed out the storage one. So if you know you need to support 32 GPUs, right? You would start, or 64 GPUs, you would start at 4 Nutanix unified storage nodes, right? And that'll give you up to 10 gigabytes of throughput. But if you need to support 512 GPUs, we can still give you 120 gigabytes of throughput on 10 unified storage nodes. So you basically know based on the GPU requirement. This is how it's going to align. You're going to determine your use case, how many users, right? What the job is, what the use cases are, what the requirements are. And when you get those requirements around GPUs, CPUs, right, you can build out your design and scalable units, and you'll know exactly how many unified storage nodes you're going to need. Okay. Now, the unified storage nodes, I want to point out too that those nodes are configured to order, right? So, meaning that you're not stuck with, oh, I get this one unit, it has this GPU, it has this memory, it has this static NVMe storage type. That's not the case. The case is depending on how much storage you need, what the requirements are around the capacity, etc. Right? We can give you configure to order on different NVMe sizes, all of that. Right? Notice we didn't talk about storage capacity in this. This is really all about what can I deliver from a throughput perspective, right? Back to my GPUs, my AI workloads. That's really what it's focused on. Capacity is a different animal. You're going to have a different requirements around that. What is my capacity requirement, right? How much storage do I need? That doesn't change this, okay? That doesn't change it. You're going to need to fill the node though, right, to get this. So meaning I can't go and say, okay, in that node, I'm only going to put 4 NVMe devices. The node has to be completely full of NVMe, right, to get this throughput what we're talking about. That's what will change, which could skew the storage requirement. But remember, you have capacity and you have performance. Obviously you're going to have to meet both. Okay. What I wouldn't do is limit this, right? I would maximize this and, understand that I'll get the capacity out of the different NVMe storage capacity types that I can choose from. Okay. Okay. So I think that's it for this week. I hope this was educational and you kind of understand where Nutanix fits on the storage side for AI. I know this is not really a primer around, okay, but what does it look like, right? I can get into that, right? So you can see here I have files here, and it's in the control plane. And this is basically the filer that I'm using. Again, don't focus on it. Doesn't match the blueprint I'm talking about. This is only a single node filer on a very small lab I have in my home. Okay, but foundationally, from a usability, right, a proof perspective, a proof point, right. I use this to prove it out, right. You can see here I have all the shares, they're PVCs, right. That's all my model storage. I also use it for my vector databases, my storage for my data ingest, all of that. It's all used for all my persistent storage as well for all my AI applications. The application I'm working on right now, which will be a future session, will be Jarvis, right? So this is Jarvis built from scratch, right? As an agent from using LangChain. And I have complete harness wrapped around this. And that's kind of what we're going to get to in the coming weeks around, okay, we have agents. We talked about the infrastructure. We talked about the platform. How do I now build agents on this infrastructure and take advantage of the platform and start building my harness around these agents? Okay. And so this is what I'm working on now. So stay tuned for that coming in the coming weeks. I think in the next one, though, I'm going to focus on topology aware Acropolis hypervisor and why that's important. And we'll get into that. And hopefully I'll have a demo of that as well as to what that looks like. Let me see if there are any questions before I let you guys go here. Okay, no questions. All right. Well, listen, I hope you have a great rest of the weekend and you have a very productive week ahead. We are, I guess, halfway through summer. I hate to say that. I'm in Florida, so I'm in forever summer. I don't want to brag, but that's kind of how it is here. Again, I hope you have a great productive week ahead. And I hope you saw that this was educational. Thanks again.
Hey. Broke down bones, dust in the air. Eyes to the ground, no one cares. Empty streets, whispers bite. Lost my way in the dead of night. Hey. Rock bottom, yeah, I felt the crack. Hey. Time to rise, time to fight back. Hey. Climbing up, no chains, no lie. Gonna find my way back to the top. To the top. Scrape knees, blood on my hands. Falling feels like sinking in sand. Echo scream, can't drown them out. Heartbeats loud, I'm done with doubt. Hey. Rock bottom, yeah, I felt the crack. Hey. Time to rise, time to fight back. Hey. Climbing up, no chains, no lie. Gonna find my way back to the top. Shadows laugh, but they don't own me. I've burned before, now I'm free. Fire in my veins, ashes in the wind. I lose, I learn, I begin again. Rock bottom hit it, yeah, I felt